Awesome.
More early mornings.
Yeah, I was up before.
This is about it.
I'm just like old now, you know? It just happens.
What do you get for? What do you get? You just get older, you start waking up at 4.
Yeah, I'm a 4 o'clock guy.
Yeah.
Mhm.
What do you do from like 4 to 8?
Meditate, workout, practice the drums.
Oh,
Yeah.
do you have a set in your house?
Mhm.
Your neighbors are chill. Yeah.
It's in the basement. You know?
Where do you go to sleep? Better than me.
Yeah, it's still like 6 hours of sleep. That's not bad.
I was like, like 11, I was there about like 6:30 stuff. It's, but I'm also like, yeah.
Uh-huh. Yeah, just wait. Mostly getting old is like pretty cool. That's just when you get injured, it takes longer to heal.
And you found
Noticeably.
you found receipts for your lab.
No.
Yeah. I think the cool people were flyer at the app site overnights. Something.
It's the other word. See, people are great in my life. It's all right.
I thought to send an email out to my lab section and see if anybody.
Yeah, my last union had like 60 or 70 applications within 2 weeks starting. Yeah, it's been 2. Hey, what's with the culture of research? Where are you people? Yeah.
I don't know. If you just like running on AIs, 50 billion people. It's like, you should stop by like the IoT or something. I know like they have like guests sometimes, like when I was a freshman, like Professor Kuzi came in and we just like talking about his research, like and I was like, oh, this is interesting. And so I just went and talked to him after that.
And then the biomath thing.
Oh, when
That's a
you
seminar.
yeah, when you present.
October 3rd. I've had like 14 postdocs apply.
Well,
That's pretty cool. But it's like, I don't want my lab to just be.
that sucks.
I mean, that'd be awesome, actually. You just kind of sit back, you just like, yeah, do your thing.
Yeah.
But it sounds fun.
Are you doing mostly, you said you're doing mostly field work right now? Or,
It's a mixture of like HPC stuff, modeling and good work, smart one.
mostly just doing like RNA-seq or just like regular sequence and
Metagenomes. Yep. And stuff.
And then you're like,
And try to save the seagrass here in Chesapeake.
that's, so you have like a plot with limbs or,
Yeah, I'm working with getting some collaboration set up there, but most of my work's in Southeast Asia.
oh, so, were you in Southeast Asia before?
I go occasionally.
Okay, oh, yeah, where, like Singapore?
Singapore,
Oh, awesome.
Malaysia.
You're just trying to like find, with the fieldwork stuff, you're just trying to find novel, like, fungi?
Yeah, right now it's like it's to the point where we do metagenomic sequencing. We've got like 1,000 samples from across the ocean, like, but we get no hits from the database. So
Mhm.
literally 90% of the fungi we're finding in new science we can describe.
Mhm.
We just have a sequence and we're like, yeah, it's a fungus. Nobody's seen it in a microscope. We have no idea. So
You do like wet lab to like.
yeah, I'm gonna start finding them and like growing them.
That's
Let's get
good.
full genomes so we can build that database.
That's good. Yeah, like a giant like mushroom fridge.
I'm gonna have several giant mushroom
That's
fridges.
awesome.
Yeah, ocean water growth facility.
Mhm. Are they doing that right now at BIMS or is this like new to them?
Nobody's doing it.
Oh,
Yeah, it's just this black hole of unknown by everybody's group. And so everyone like sees them there and they just like, and there's fungi, and then they run away from it. I'm really fucking tired of everyone just ignoring this.
yeah. It's pretty fast to turn around time for wet lab too, right? Well, once you get a sample, it's like, it's a problem.
I just extract DNA and ship it off. Other sequencing.
Yeah.
So the molecular, I hate molecular work. I find it tedious and difficult and boring and expensive. It's like way faster just to ship it to the pros. 60 bucks a sample. I mean, computer like robots are doing that stuff now.
Yeah.
It's one of those skills that you can spend 3 years getting really good at pipetting, and
Mhm.
you'll never get a job doing that.
Yeah.
Every company has a
Yeah.
open job, yeah. Not to scare you all completely, but like, there's no jobs anymore. Robots and AI are taking over everything. And sorry. What's even the point of the
Yeah, I feel like the next thing.
it's not bad, yeah. AI's like ChatGPT does real good at Bash.
Alright.
Because Bash, you haven't seen it as a scripting language yet, but it is a fully fledged programming language also, and it's just unreadable. It's awful. So I need a crazy function and weird test cases, GPT. Very weak. But it does a really crappy job at managing your files and interacting. So over here. We're going to start out with the quiz. Okay, no GPT allowed. Here it is. Log into Bora before you do this. Part of the quiz.
We get forward. Honestly, on board.
How did that? You don't have biocomputing to do this on
Simply the time we're starting,
your home. Yeah. Log into the APSC board cluster, go to your home. Inside of Biocomputing or some other folder, make quizzes, put those 8 folders in it. Inside quiz one, make a readme in that text. And show everything. Tree works there, the HPC.
Second.
The minutes, but. Control C stops that. Backgrounds. Okay.
Like to.
Choose the color of the thermal.
Yeah.
What the? Oh,
You're a window or if you're a shadow, there's a using some like other papers.
Great.
Yeah.
So I did that. Okay.
It's a little bit.
All right.
The red is.
Tell me what you got.
Yeah.
How do you? I think I mostly that's the element stuff like. Well. I don't think they have it.
Okay. Bora. All right, what did the quiz say? Make directory, quizzes. Go in there, make directory. Quiz. Code. 8. Nano. Quiz 1. readme.md. This is quiz 1, control O, control X. Oh, no tree in Bora, my bad.
Fine.
I'll do fine. The end. Okay. Yes,
Question, so if we didn't use like a shortcut, is it still fine, and we got the final result?
the final result is what it is.
Okay.
Yeah. So if you did them one at a time, that's between you and your God. Learn the shortcuts because
Yeah.
you're gonna be dealing with hundreds of thousands of files all the time. That's fine. Yeah. Okay. Problems. Thoughts, concerns.
It's like, here's a push this in there.
No. I just wanted to see basically this output.
Okay.
Can you in 5 minutes make 8 directories and a README file? The answer should be yes. At this point, definitely because you've been practicing this for hours. Okay. If you haven't been practicing for hours, you might struggle a little bit with this. If you have spent a couple hours doing this over and over, it would take you about as long as. That's where I need you to be with this material and the other stuff that we've covered. It needs to be, oh yes, I can do that, no problem. Because as this class starts picking up speed here, starting today, everything's cumulative, and we're going to be hitting it pretty hard in the next several weeks, learning more and more stuff. Okay, so that's quiz number 1. Now, not everybody had biocomputing on there, and that's fine. You don't need it on there yet because we can put it on there from your computer. We can just upload it straight onto the server. So we can have kind of this copy of biocomputing directory online at HPC and on your computer and on GitHub. So 3 separate spots, same folder. Okay. This will get tricky. Let's say you do some stuff on your laptop locally and you push it to GitHub at the end of the day. A week later, you log into the HPC, go into biocomputing, it's not there. Why?
You get full.
You gotta do a git pull. So since it's a Git repository, you gotta do a git pull. And if you forget that part and you make some other files on the HPC and try to push them to GitHub, it's gonna say no. It's gonna say, sorry, but I've got changes from this other computer. It doesn't know that it's also your laptop. Right? I've got changes here. You're saying stuff that's gonna conflict with those. The answer is no, we can't do it. So then you gotta take your files, save them somewhere else, do a git pull, put them back in, finish it. I'm making us do it this way on purpose so that you have to deal with this problem, because this is a problem that is ever present. You're working with this stuff. So how do we get our files to the HPC? There's a few ways. Some of you may be able to download FileZilla. I think on Windows, it's not happy with it. And so for Windows, it's WinSCP. This is a nice little GUI, a graphical user interface that lets you click and drag files from a server to your computer back and forth. All right. So I'm going to open up FileZilla, and it looks like this. The left-hand side is my computer, the right-hand side is some server. All right, Control S lets me start to log into stuff. So look up here. SFTP, Secure File Transfer Protocol. The secure shell, that SSH. And then we're giving it, we'll do Bora here.
when you site? Or does it matter like what kind of site you make there?
Oh, yeah, new site. I got it.
Does that matter like? what
Which
you
means-
No, whatever you want to call it. Call it Bora probably. Your user, your password, and that's it. Always trust this host, yes, please. And there it is. So that's handy. I can just find my biocomputing folder on the left side, drag it over into Cyclone. The files can go back and forth. Here's my biocomputing. I see quizzes there now, and quiz one. My computer, I have to go to desktop, hit repositories, there's biocomputing. And I've got nothing in my quizzes. So I'm looking at that and saying, oh, I want all of these, highlight them all, drag them over. Yeah, I've got them on my computer.
Good question.
Always trust this.
Okay. Let's just do
Yeah. So check the little box
Say.
and say, oh, yeah. Okay, this is just one way. There's a lot of programs out there you can download to kind of do this thing. FileZilla's classic, WinSCP if you're on Windows. Yeah.
I hear like, I know if you go like on a Mac,
Mhm.
they have, it's like, I'm not sure what it's called, so like you go find your pay. You like connect to the server.
Yeah, Linux has this too, Windows doesn't.
Okay.
So look at this, I've got just a folder at all times. It's got to connect here. But that's my Bora. It's just here in my Explorer.
Is there like a way you can like do that, like, can I just do something just before that site phone?
Yeah. So let me show you how it looks. Usually it's connect the server somewhere like this. It's SSH:// G's on at Bora.cyclone.wm.edu and then connect. Very handy just to have it in your Finder. You can drag stuff in and out there.
You just open the
It opened the terminals.
Yeah, I did that and just opened the
That's done. Yeah.
Sorry, mine is having difficulties connecting.
Let's see.
Yeah, I could have, this is the host, right? Like I was looking for it.
Bora Cyclone, WM.edu, secure FTP, users just your name, not the app. Yeah.
Okay. How did you get
Control S.
for Mac? It's Command S.
So command us to get,
Like
New
this
site.
one.
okay, and then,
Yeah.
sorry, what do we need? I think I missed some stuff, so I'm here and then.
Host Bora Cyclone, WM.edu.
There's-
Login type, you can change that to normal
Oh, and it's not.
user and put your password.
Then you just do connect.
Host is just the Bora parts. Delete everything left of the. Bora.cyclone. .wm.edu. Then log into that normal, and I want this to be secure. Just file transfer. At the right top. That. Yes. That. And your username and password. You got it. Is this WinSCP or FileZilla? Sure. Always trust this host. It's okay. There you are. You got it. Not connected, it says, oh, yeah. So Bora.cyclone.wm.edu.
Oh, for the user.
Oh, no, for a user, it's you.
Yeah, you're replacing my users, like I would type my name in, but I come back to this for me, fix whatever that happens. It's.
Go ahead and put your name there, and then we'll change the host too. That should be Bora, cyclone, www.
Yes, this one was like.
Yep, always trust this host, yep. There you are.
And what are we trying to this? This is like, where, I mean, I'm making something.
Okay. Okay,
Is that going?
that's a good question. All right, so I've got both mine pulled up now. Or somewhere. Yeah, there you go. There we go. Look at this. This dot dot. What's that mean? Go back. Okay, so this is my biocomputing, and it's got a bunch of stuff in it because I've been working there. You probably don't have that, or you've got a little one that you've just been practicing on.
Hmm.
Do you have stuff in there that you don't care about, or that you do care about?
Not really.
Great. So I would just come over here on the left side, which is your computer, and drag that whole folder over.
Like from the left to the right.
Yeah, from left to right. Left is your computer,
Okay.
local. Right is host.
You did see that? You go to Bora, does it still have like your GitHub log?
Yep.
Okay, wait, so do I drag it and do this thing like it's here, or is that gonna go in?
It'll go into any of those, so you can scroll down, or you can just copy and paste. Yeah, drag it over here onto a file.
Onto this?
Yeah. There you go.
And then it's, I just, this is the one.
There it is.
No, that's like,
Oh, yeah, well, it's connecting.
Go back.
Yeah.
Just the cycling one.
It's very good.
Ta-da. Did you drag it into a folder over here, maybe?
I pre. And then like, it's like over here, and then this is the. Up here to just. Like, do the quizzes.
Where are you? What's your user?
So then I just dragged it like under like. I did that.
Oh. Wait. Right here. Okay. That's great. All right. And you want sometimes all the body. Don't. Yeah. I'm just gonna drag it over here.
Okay. What I'm worried about is that.
Drag it somewhere else.
Yeah, so it's somewhere. I'm worried I put it in somebody's.
You might have put it in somebody else. Now, typically, you can't write stuff to somebody else's because they've got permissions that say no write.
Yeah.
Yeah, so I wouldn't worry about that. You may have dropped it into the home. And so now there's a biocomputing just sitting there where everyone's files are. Let's see. So PWD, Cyclone Home. I'll list everything. One in the previous folder that is biocomputing. And sure enough, there it is. I'm gonna see if I can remove it. I probably can't. No, I can't. Because you stuck it there. You can remove it.
Should I do that with you?
Yeah.
Okay, I'm still calling.
So what you would do is CD, then CD dot dot takes you into the home. And if I look around, this is all the users. And oh, I got rid of it. Okay.
Oh.
I don't see biocomputing there. Cool. All right. Get back to mine. I can just say CD. So now I'm in Click on home genome. Okay, so that was kind of fun. This is a nice way of doing it, but you know, these programs have a bit of like bloat and adware and all that garbage. And the main problem moving files this way is what? It's not reproducible. How come? How do you tell somebody how to do this? You have to sit them down and give them a lesson and then tell them exactly what file to move. Now click it and drag it to the right. No. This is nice and convenient, but it's not to be used for any serious work where you're trying to be reproducible. So the reproducible way would be to do this on the command line. So I'm going to go here. I'm logged into the server. See that? I'm going to exit. And now I'm in my biocomputing. That's where I want you to be on your local machine.
Oh, so no, we're on the.
Exit page.
Exit the HMC. Now, before, when I type Bora, it's doing SSH, Ethan, Bora, dot, blah, blah, blah. I'm going to copy the login and host name. And instead of SSH, SFTP, the same thing. This is a different way of logging into a server. Before we did secure shell, meaning that we are getting a shell interface with that server. SFTP stands for, any guesses?
This active file transfer.
File transfer protocol, yeah.
Mhm.
And that's all it's for. It's moving files around. This is the original OG file transfer. Well, FTP was, now it's secure. Back in the Wild West days of the early internet, there were no passwords. Madness. So that, gonna ask for my password. And check out my little prompt now, it just says SFTP. Now, most of our bash commands don't work anymore because we're a file transfer protocol, we're not in a shell. But we've got LS and we've got CD. And so the commands I want you to know are for here, LS, CD, you know those. And then there's get and get, put and input. Get a file, multiple get files. Put a file, multiple files. Put. So that's all that you should ever have to worry about with SFTP. Get and put, what do you think they do? Which one's which?
Yeah, it's good.
What's that mean? From the server to the local. That's it. Okay, so if I want a file, I see that I've got this in CBI error report.txt. So I would just say get that. The end. Do the same thing for a whole folder. This makes it much more reproducible because you're scripting your commands that can be written down, followed exactly. And the best part about FTP is that to leave, you say bye.
Isn't there autofill?
No, isn't that beautiful? It's so old school. I hate it. I think it's kind of terrible. But you will find yourself having to use this. The most common in genomic land is when you get sequences back from a sequencing center, they will provide you an FTP link. The end. And they will say, here is your temporary password and username. And that's it. If you don't know how to use that, you're screwed. There is no download button from the sequencing center. It's just Here's our server address, here's your username and password. You have 30 days to download it before you delete your stuff forever. So that's how it's done.
Where did it go? So like you like fetched it and we got it?
It went to where I am, so I should see it right there. So it goes to whatever folder you were in when you established the connection. Yeah,
Okay, so if I had a file of the same name as that file I just copied, just overwrite that file.
yes,
Okay.
forever,
I
permanently.
think that was the same thing, so.
You know, at this point, having your stuff deleted isn't the worst because it just means you gotta do it again. With more practice, makes
Yeah.
me happy. I sleep better at night knowing that you have to redig the ditch. If it's good for you. Alright, so that's another way. So we've got like something like FileZilla, which is just a GUI version of SFTP. And then we even did that. We said SFTP, here's our address, and it kind of abstracts it all and makes it great for us. But this is the command line way, and of course, the ultimate final form way is using Git and GitHub. Right. So I'm going to log back into Bora. Okay, I look around, I see biocomputing. I'm gonna remove recursively biocomputing. And in fact, I'm gonna do an RF, force removal without asking permissions. Because I've got a bunch of files in there that we will have to get to remember that. It's gone. No takebacks. This is your reminder, be very careful with that command. If it's confused. Just if you accidentally gave it the wrong file, too bad, it's gone. Yeah. Well, it's not actually gone because it's on GitHub, so what can I do to get it here? Not get pull. I can't get pull because I'm not in a Git repository.
Okay, clone.
Git clone. Go ahead and clone it in.
Is this just using the home directory?
Yeah, home directory is probably your best spot on the server.
You said destination plan already exists and not mentioned.
Because you didn't remove your biocomputing yet.
Okay.
So you're trying to clone something called biocomputing in all caps.
So
It sees that it's you've already got a folder there called that, so it won't let you. So you'll need to delete by
Okay.
saying
Do I-
RM.
you want us to delete the one that we just moved from like the local computer or the one that we made in Word already? Like if we already had a folder and then like add, you know what I mean?
So you had a folder,
Yeah. then we
Already.
actually made it in Word,
kill it,
kill that one.
kill it. It's not a Git repository. We want this to be the Git version of that.
And deleting everything in here doesn't affect it. Like your local area.
Not your local, yeah. But keep in mind, we want biocomputing to be the same on your local HPC and GitHub.
Mhm.
You keep it the same by saying GitHub. All right, so kill that and then clone it in and If I say ls-a to show hidden files, you will see a magical folder called .git. That's what makes this a Git repository. The one that you just made earlier didn't have that. It wasn't a Git repository. I can go into that magical folder. Got a bunch of stuff. Cat barfs up the contents of the file. Config. You can see that it's saying, here's the URL. Here's how I fetch things. Here's the names of my remote. Here's the name of my merge branch. Bunch of stuff. Okay. Every time you commit, right, add and commit, it saves a snapshot of your entire folder here inside of .git. My quizzes are gone. I just deleted them, right? So the version online didn't have those quizzes. So I'll need to remake them. So I have a spot to do quiz 2 next week. Okay. I've got a README file here. I'm going to drag it from the HPC over to my desktop. And I'll just use FileZilla. I'll stick it here on my desktop. Beautiful. readme.md. Great. So this file exists on the server and now on my desktop locally. My shell is here on the server. And I'm going to show you something called MD5 sum. You heard of this? This is a hash digest. These are really common, especially when downloading big files. If you go to NCBI and look up the human transcriptome, it comes with a big string of numbers next to it that is a hash digest of that file. This is an algorithm that goes through every 1 and 0 in that file in order, and it spits out a fingerprint. If I change a single byte in that file, a 1 to a 0, or I delete a 0, or whatever, if I change anything, it changes this fingerprint completely. This lets you check to make sure that files are exactly the same. It's not just the file size or anything, and it can do it with any size file. So you can have a 50 terabyte file and run MD5 sum on it. It may take a few minutes to run, but you'll get a fingerprint and you can quickly check if the file is the same, exactly the same. This is very handy for downloading big files because corruption happens. You download the human genome, you want to know that every A, T, C, and G is exactly the same as the human genome there, especially if you're looking for like SNPs associated with diseases. Dropouts, corruption, static noise, that can change things when you're downloading. So you look at the MD5 sum that they have on NCBI, and then you're going to compare. I'm going to open myself a brand new terminal. So I got 2, and look, it says you will never be good at this. It's still telling me that. I'm going to go to my desktop, and I'm going to do MD5 sum of that README file that I just downloaded, and it should be exactly the same. Yay, I'm happy. I'm gonna go into that, and I'm gonna add a dot right here, save it, exit. Oops. Do MD5 sum, look at that. Completely different hash digest. not one dot. So when you download big files, use this. And as we start learning logic and flow control, how to say if, we can compare these automatically. So we'll download it and we'll say like, if this file's MD5 sum is the exact same, then proceed, otherwise throw an error. Yes.
Can you use the SFTP to move something from your computer to Aura or
Mhm.
you know?
Yeah, you can. You just say put instead of yes,
And then it goes to the directory
where you are.
where you are.
And you can use CD to kind of get around in there and be where you want to fit it.
So, cause it changed like to a completely different, you said, all that fingerprint.
A fingerprint,
Right,
yeah.
fingerprint, so if I were to delete that dot that I put in there, does
It
it
should go back.
Okay,
These became kind of famous because this is how people store passwords. So your Amazon password is stored as a hash of your password. Yeah. This was great news for hackers because they just ran an algorithm that started looking at every single possible combination of letters, 1 to 16 long, and they made a hash digest of all of them. And so they have a lookup table now. And if they see a hash digest, they can look it up and say, oh, here's what that password is. Neat. So MD5 sum is not secure anymore. So it's not good for storing passwords. Plenty of companies still do. Oops, they don't care about you. And so this is what happens when like, oh, your password was compromised. Yeah, they're still storing it as an MD5 hash. If they hire incompetent idiots. Doesn't matter. So we don't care about that though, because we're not storing sensitive information. We're just trying to compare if files that are exactly the same. So MD5 is still the fastest algorithm, so it's what we use in bioinformatics. The idea with these hash fingerprints is that you can't, without building a lookup table and doing like trial and error, you can't predict what the contents of the file are going to be from that hash. But if I were to nano this, get rid of that dot, save it, MD5 sum, and it went right back. But it's deterministic, but chaotic. Okay. Questions about moving files? I don't care how you do it. In general practice, I usually use FileZilla, or better yet, it's just sitting here. I have to log in. But it's just right here on my computer. Mac's the same way. Windows, you gotta get it like this. Or yeah, Windows. Ready to move on? Let's do it. All right, I want to get back. That in the terminal. All right, I'm back online. Who am I? He's on. Okay, cool. Echo $0. This is your first environmental variable. And that is just what shell is this? So there's a variable that's 0. And if you want the value of it, isn't that clever? Put a $sign in front. So let's try one. I'm going to set a variable. My variable equals 1, 2, 3. So it's set a variable. This is temporary. It'll be gone as soon as you close and reopen. But here it is. Echo my variable. Echo dollar my variable. Oops. What's happening?
Looks like echoing the text versus like echoing you, like. No, it's like the variable.
The value of it.
Yeah,
Yeah. So just because I've got some variable in there, I can't call it without using a dollar sign. I want the actual value. And so same thing with $0. Zero is just the character zero, but $0 is the value of variable zero, which in this case has been set to bash. If I type in ENV for environment, this will show me my environmental variables. And there's a bunch. Holy, yeah. Wow, they've added a bunch more than I'm used to seeing. Look, there's a variable for PWD. Every time you change to a new directory, it resets that variable. My log name. The printer. Yeah, there's no printer attached to the APSC. There's my user. The library path, that's where it's looking for things. Okay, so we've got all these environmental variables that are just kind of sitting around hidden in the background. We can set our own. But the important ones, if I echo PS1, and this is a really important, but it can be nice. That variable is what's displayed right here as my like prompt. User at host, and then the working directory $$. That's what I'm seeing here. So if you want to change the way this looks, you can. You can get rid of the at host if you don't like that. You can have it show you the entire working directory. So you're looking at like your absolute path at all times. The PS1 is one. Echo $home in all caps. That's your home. Always nice.
So I did the echo PS1, I got something different.
Yeah, I'm sure you did. I changed mine.
Oh, yeah, sure.
Yeah.
So this isn't one that came with HPC?
No, I made this one myself. What do your guys look like? I don't remember what. Holy,
Like 30
crap.
frames.
I was like, "Hmm,
That's a whole bunch
it's
of
gonna be really-"
stuff. Well, it's been several months, so I forgot how bad it was. But you can see why I changed it.
So space one meeting.
It's just the login prompt.
Oh, okay.
Yeah. So it's what comes in front of the blinking cursor.
You said this like the same way, like how you did alias?
Yeah. Yeah, so I could say PS1 equals, and then in quotes, user. And I'll get rid of the host. No, I like it. User at, because I sometimes and then different ones, so at host, then a space, then my current working directory, $$, and then close the quotes.
So if you want to see when you have to like, is like the environment file, like in the home directory, you have to like go to that one.
Where did we put our alias?
In the bash RC.
Bash RC. So if you want this to happen every time, you need to copy and paste that into your bash RC.
And like,
We're gonna be seeing that a lot when we set environments. We're doing that today.
what's like the point of this? Like, what's like the use case for like that? For just having everything like, it's just like text. if that's the P, what do you use PS1 for? Like, if you're-
It's just what I'm seeing, so it's like customizing the shell for me, just like changing the background. It's just, so I'll change this. I'll get rid of at post there and look at my prompts now,
I
right?
don't know if it's been around here, like, it's changing stuff.
Oh, yeah, it's real. So it's
Yeah.
literally what's showing up right there.
Wait, so what? How did that get rid of? Like, how did that? I don't know, like, why did it delete some stuff but not others, I guess?
Okay, so I will say \u is user and you just Google this, right?
Okay.
At the host, then a space, and then my working directory, a colon. That variable, like, is always what shows up as your prompt.
Okay.
Yeah, we're in here, you know, just remember.
So,
Oh, you're using the dollar sign.
No, I think that's from me.
Oh, PS1 equals.
it's a second level.
Did you copy and paste that in from the document? Ooh, this is fun. Yeah. All right, so Sophie
I think they're noticed.
wrote it here. Copied and pasted it in. Well, what is this? Is this Google?
Yeah.
Google Docs. The double quote is a different character than an actual double quote. And if you look closely on your terminal, you'll see that it's like, it looks italicized versus the real one. Ooh, tricksy, right? Isn't that horrible? Okay, so careful with Google Docs and Microsoft Word. As a matter of fact, the answer is no. Don't ever use Word or Google Docs for copying and pasting. They have all these hidden characters and a bunch of garbage. They're terrible. What do you use? Just the most boring, like basic bitch style text editor. It's just text. It does no highlighting, nothing fancy. That's what we want. So I use the little like built-in notepad with Linux, text Wrangler, I think, on Macs, text editor on Windows. No frills, and they don't do that. Weird clothes. But that should fix the problem. Yeah. I'm glad that happened early.
So, I just think, so is PS1 like already a variable in the environment file?
Yeah, it's an always variable.
So how do you edit the environment file then? If you-
We just did.
Just, does that get saved though?
Yeah. Oh, well, not if I log out and log back in, it doesn't get saved.
Yeah.
How do you make it last from one session to the next? You have to
Oh,
put that
okay.
this assignment into your .bash rc file. Just like any alias that you make. Okay, but before we do that, because we're gonna have another one, here's the most important. $path in all caps. This is the most important environment. Variable. You will not have all the stuff that I have. All right, let's look at this. You probably have that, right? Sorry, 23.11.9 bin. Same thing about SBin. What else do we got? Okay, so you got a few. Notice when I double click, it's only doing bits of it. They're separated by colons. Each one of these, user local bin. Each one of these is an absolute file path starting at root, going somewhere into the computing system, and it's just getting a folder. And it's a bunch of stuff. So basically, path is a bunch of folders where it looks for programs. So if I type ls, that's a program. It lists files. If I type which ls, that's weird. User then ls. What's going on here? Which tells me where I can find the program. If I say which your mom, it says know your mom in any of these locations. Right, so that program does not exist in my path. Get used to me saying, is that in your path? Because you're going to be having troubles all semester, and it's probably because it's not in your path. A path is a list of folders separated by columns where your computer will look for programs.
So when we did which LLs, like what is the output?
The output means that the program ls is actually a file in root user bin ls. So I can list that directory, and there it is. Now when I was doing this, I left out a space after. Okay. All right. So this path, echo path, dollar path. Let's see the value. These are all the locations separated by colons where your computer looks for stuff. So you type in pwd. First, it looks in here. And it doesn't see pwd. Then it looks here and it doesn't see it. Then it looks here and it doesn't see it. If I say which pwd, user then pwd. So it didn't see it here, it didn't see it there, didn't see it there, here. There's where it found it. User bin.
Just to clarify, so each of these are separate programs between the
Folders,
folders. And they're just containing this information.
they contain the actual program itself. So there's a program called pwd. It is a file, a binary file that makes the computer do fancy things. In the end, it just prints out where you are. But when you type pwd, it's not like your computer magically knows what that means. It looks for a file called pwd in these locations. If it finds it, it will run it, it will execute.
So if I navigate to that,
I'm going to go to user bin. Notice the root there. And I'm going to look around and look at this. Bin stands for binary, right? So these are, look at all this crap. Right, so when you type SSH to log into something, that's actually a program. Matrix at SSH. Woo! There it is. Yeah, it's binary. So gobbledygook. Ones and zeros. It's been compiled. But you will be able to see pwd. There it is. So I'm gonna get out of here, go back to the home. Echo dollar path. So why am I hitting this one real hard? Wait, yeah. Hit Control C more. What? Oh, it's totally broken, yeah. I'm not- Let's try to exit.
So you have to.
Oh.
Yeah.
Yes. It's okay. Yeah, we just wanted to say, yeah, close anyway, that we started. Yeah, get that, yeah.
I'm not able to actually go and I think it's
All right. Sophie has tried this. Fail. You're starting from home. That tilde means home. That is not that's not the path to user bin, it's root. There you go. That's your. Oh, garbage again? Oh, no, oh, okay. I was like, what? All right, so it's work. I don't know what happened there. Never seen that before. But no harm. Okay. I'm hitting this real hard. This idea of the path. Because it needs to be intuitive for you, so. Why am I doing this? I guess it's so important.
Like, is it that because of different paths have different binaries, different settings? Is it binaries?
So different programs, right?
Yeah.
Look, I've got this that you don't have. So I can say meta wrap. Oops. Oh, wait.
Things have a value.
Oh, I deleted it. I remember. Hated that program. So I can say R. And now I'm using R. You can't do that. Go ahead and try it. I get to say that because I have told my path variable, hey, here's another place I want you to look. And so when I downloaded the R programming language, that's where it got put. And so then I have to tell my path, hey, I know you want to look these places, but I've also got some custom spots I want you to look. So we can do this. Export path equals $path colon, and then whatever, wherever I want it to look. Okay, I want the variable path to be the current value of path, and then a colon, and then some new location. Notice that these are absolute paths. They all start from root. Now you can do whatever you want here and it's fine. It won't hurt anything because you log out, log back in, it's gone. Yeah, in your Cyclone home username, something, biocomputing, whatever. Now if I echo value of path, there it is, tagged on at the end.
You have something like that person file, like the paths that you like those new paths that you had that we don't have.
Yep. So here it is. At the end of my .bashrc, I've got that little line there. So anytime we install a program, this makes it really convenient to use. Otherwise, you have to, every time you say R, you have to say root cyclone home G zone programs are 4.5.0/ben/r. That sucks. So we just add it to the path.
What's the match supposed to be?
Dot home. Dot bash rc. I don't care if you're on a Windows or a Mac at this point, you've got a dot bash rc because we're using bash on HPC. All right, so I've got my aliases in there. All the junk that they put in. Don't change this up unless you know what you're doing, okay? And I just changed that with nano. So save that file and then it's gonna export path equals path plus the directions to the now defunct meta route. And path equals path that includes that with directions to where I put R. And it's separated by a colon. This is technical term for this, it's variable expansion. That's what we're doing with that $sign. Expands that variable to be all of this. And then a colon. And then this new place. So we've got all these environment variables. We will be modifying our .bashrc to include paths starting next week when we start actually downloading some programs to use. But for now, I think I want to move on a bit. And we're in lesson 3 at this point. So we're here in Bora. And what I want to finish up with today and let you do the rest of lesson 3 on your own is this idea of streams. They're always present, and there's always at least 3. And they have names 0, 1, and 2, also known as standard in, standard out, and standard error. Okay, so if I say echo hello world, let's spell it right, there we go. Three streams just happen simultaneously. Standard in, standard out, and standard error. Okay, so here we are. We had a program, had a standard in and standard out, and there was standard error. Where were they all in this process? What was the program? Echo. Echo. That was it. Echo was a program. If I want to know where it lives on the computer, I say which user bin echo, right? Okay. So that's the program. What was the standard in?
Oh, space scroll period.
Yep. Stuff inside the quotes. Standard in. Think of it as the stuff from the keyboard, usually, by default. So it's the stuff that we gave the program. And then the standard out.
I think that's something that.
Hello world again, right? So we had our keyboard give some standard in to the echo program. It took the standard out and stuck it to display. That's the default path for everything. What happened to our standard error?
It didn't mix it.
It did, it's just empty.
Oh,
Yeah. There was no error, and so it's an empty stream. That stream is actually running. It's a process happening in the background. Alright, so here's your spoilers. Yeah, the program's echo. Standard in is from the keyboard, the standard out is to the screen. Error also went to the screen, but it was updated. I'm gonna go into make sure I'm in biocomputing. Go into my lessons. Of the 3. Oh wait, I don't have an O. For now, lesson 3. Wherever I'm taking my notes. So I've got some notes here. And this right here. Very important. Greater than is a redirect. So look at this diagram again. We've got our keyboard giving standard into a program, and then standard out goes to the display. We can say no to that. We can redirect that standard out to other places. This is where the terminal is actually starting to become useful to us. So echo, hello world. Again, I spell it with an E. Okay. Hello world. That goes to my screen. I can redirect it to any file. Go ahead, echo something and redirect it to a file. If you give it the name of a file that exists, it will overwrite it instantly. No questions asked. So it's a bit dangerous in that regard. Got a program, I gave it my standard input, which was stuff in quotes from the keyboard. And then I told it, hey, your standard out, I don't want that coming back to my screen. I want that to go into a file. And that file name will be file.txt. So I can look around and there, it created it for me. Hello world, 2 greater than, send it to error.txt. Why does 2 greater than work for the error string? You remember, they all have numbers. 1 is implied, that's your standard out. So we could say echo whatever. Send the standard out to file.txt. I can send the standard error to this error file. Note the behavior. This first one, no output to my screen. Where'd it go?
To the file.
To that file. Second one, output to the screen. How come? It stuck it to the screen this time. It didn't go to a file. Why?
This is the arrow thing is saying to do 2 is gonna get written to that thing. And the
Right.
first part is gonna go there.
Yeah, so I didn't redirect the standard out. I just redirected the standard error. Yeah. I could do both. Standard error and out to file error. Okay, so I've got my file.txt. I look inside of it. So I can echo stuff and send it to a file. I can have the output of any program sent into a file. So ls, it lists things. It's a program, so it's got a standard input, and that standard input is what? The stuff in that directory. Standard output goes to where? The screen in most cases. That's what we've been doing this whole time. We say ls. It's got standard input, which is current directory, and then it sparks it onto the screen for you. Easy enough for me to redirect it to files. And then I can cat files. There it is, the contents.
For the one we did two and the and one, is the echoes the 1, 2, 3, is that supposed to be in the file error files?
It should be in file error. Oh, it didn't show up in mine. I always get confused with this. I think it's one. There we go. No, I'm forgetting how to do it. Fine. Oh, it's because there's no error. That's what's happening. The error is empty, and so it's writing nothing in that file. I'm like overwriting that file with nothing.
Then the out, so
There's no error.
so is like this sequential thing, so if I do 1, then point to 2, then the other.
I'd have to test that. In practice, I never do this because I always want error going to a different file in my output. You can see that I just fucked it up. I did it wrong. So this idea of redirecting is actually really powerful. You run some bioinformatics algorithm, you're counting the number of sequences in a file and seeing their GC composition. Cool. Well, do you really want that on your screen where it disappears the next time you turn it off? No, you want that going to a file. So you direct the standard out to the file. If some errors happen, you want those going into the error file so you can look back and see like what went wrong. If you do 2 of these in a row, it's append, not overwrite. So echo 1, 2, 3, send it to a file called W. Why not? Okay. At W. Every time I did that, it's appending it to the end, just tagging on lines at the bottom of the file. So this is safer because it won't overwrite your file, but it might not be what you want. Now there's another way to redirect. We were looking at redirecting to a file. This is the pipe. It's above your enter key, the vertical bar. LS. There's all these chunky files I've been making. LS, pipe, WC, word count. Seven 58. Guesses on those numbers. WC dash help. Print new line, how many lines, how many words, and how many bytes in a file. echo, hello. Pipe, word now. Hello, mom. Seems deceptively simple, right? But what's that pipe actually doing? It's saying there are two words, hello, mom. There's one line, and there's 10 bytes. Okay. Before you get out of here, I want you thinking about what that pipe is and what it does to the standard in and standard out of both of those programs. We've got two programs there, Echo and WC. The pipe, as in bioinformatics pipeline, the whole damn point of this class is that pipe, the idea of passing standard output from one thing, from one program, become the standard input to another. If you know about 20 of these little commands, echo, WC, grep, sed, sort, unique, cat. Seriously, there's like maybe 20 things that we're going to learn in here for bash. It's how we put them together with that pipe that lets us ask really complicated, interesting questions from huge amounts of data all at once. So go to it, finish lesson number 3, and be ready for your assignment 2 is due Thursday.
You want that Thursday before class? Or just-
Yep, I'll do another git poll here. Oh, for anything, WC, any program, dash. Help. So if I say ls-1, that gives me all my files, 1 per line. I can type that to WC-L, which is the number of lines. And boom, I've got 7 files in this directory. There are 657 users registered on this high performance computing system. I know that because I'm in the home. Each one of them has their own folder, and there are 657 of those. That's what we're going to be doing all semester, is finding creative ways of putting together a very simple program to ask complex questions. So work on that. Think about those streams while you're working on this lesson.